Okay, so we will do more examples on the loop. Can you hear me, guys?
Yes.
Okay, but my screen has become slow. Okay, I think now it's better. Okay, so let's do more for loop examples. Okay, and yesterday we did basic programming. So let's extend it to next level. Okay, now today, okay, let's say I want to generate numbers, okay, between 1 to 1000. Okay, so let's say print all the numbers. Okay, print numbers, print all the numbers between 1 and 1000, which is perfectly divisible by 19 and 51. Okay, between 1 and 1000, which are perfectly divisible by 19 and 51. Okay, so here what I'll do, okay, I'll say start and end equal to, you have 19 and so because in the for loop, sorry, not 19, starting is 1 and ending is 1 more, right? So I'll put this as 1001. Okay, and divisible. Okay, so num1 comma num2 equal to 19 comma 51, right? We have discussed that you can assign multiple variables in same line. So when I'm saying variable 1 comma variable 2 equal to value 1 comma value 2, so it would always do left to right mapping. That means your leftmost variable will take leftmost value. The rightmost variable will take rightmost value, right? First variable will take first value, second variable will take second value, right? So that's how generally it works, isn't it? So now I'm going to say for n in range start comma end, right? So it's going to generate values from 1 to 1000. N will take the value. First n will be 1, then n will be 2, then n will be 3, so on. Now I need to check if, okay, if num mod num1 and, right, both we are saying perfect divisible by both 19 and 51, and n mod num2, if this and this, okay, so this should be equal to 0, right? Perfect divisible means when you divide n by num1, it should be 0, and same thing, this should be equal to 0. Then we print n, right? And we can say n equal to, right? Simple. Now let's run this and see what happens. Okay, so only 969, this is the only number which is divisible by both 19 and 51. Okay, and of course multiples of this will also be, so if I make it like 10,000, then you will see more values. Okay, right? Because 19 and 15 both are prime numbers, obviously, right? So prime numbers will not have any common numbers that will divide both of them. So the lowest number that is divisible both of them is multiplication of both of them. 19 and 51. Okay, so it actually checked, it ran like one with 19, one with 15, it checked all the 10,000 values, and it says that only these values are divisible by both, okay, 19 and 51. Okay. Now let's do one more example. I want to generate, okay, I want to generate prime numbers between 1 and okay, so here, okay, let me write the problem first. Generate prime numbers between, say, 10,000 and 50,000. Let's say between 10,000 and 50,000, how many numbers are prime numbers? Okay, so, okay, we'll start with start and end, right? So here it is, okay, and here, okay, we know that 5,000 is not a prime number, so it doesn't make sense to make it 5,001. Okay, 50,000 is enough. We don't have to make it 50,001. Now, you have to take a number between this, right? And we need to check if this number is prime or not. So this logic has to change, right? What is this logic? This logic, okay, here you see, again, we have to take 10,000, okay, and not just with num1 and num2, we have to check with all the values other than 1 and itself. So what did we, how do we define a prime number? Prime number is number which is not divisible by any other number except 1 and itself, because every number is divisible by itself and 1. Itself into 1 is the itself, right? So every number is divisible by 1 and itself. So do we have any numbers between 10,000 and 50,000 which are not divisible by any other number other than 1 and itself? So here again, I'll have to run a loop. Okay, instead of num1 will be for num1 in, okay, in range from 2 to num1. So you go up to num1, right? And here we need to divide. So if, now you see here, okay, so you're taking a number and you're dividing, okay, so it may not be divisible by, let's say, 2, it may not be divisible by, let's say, 3, but it might be divisible by 5. For example, 10. 10 is not divisible by 3, but it is divisible by 5, isn't it? So we cannot just check one value. We have to check multiple values. So what we will assume is, we will assume that every number that you take is a prime number. We'll assume that every number that you take is a prime number. So this is where we are checking the number is prime or not. This is just to feed us the values from 10,000 to 50,000. Okay, this loop will only feed us one by one, right? Take 10,000, 10,001, 10,002, right? But actual logic of checking if number is prime or not happens here. So here I'm going to say is prime. I'm defining a variable is prime, and I'm assuming that it is true. Okay, so I'm assuming it is true, and now I'm going to divide that number with every other number. The moment I know that number is not a prime, I will change it to false. And then I don't have to continue further. So for example, you're checking from 1 to 9, but moment you get 6, 6 is divisible by 2, then you don't have to check for 7, 8, 9, 10, isn't it? Okay. So it is, I mean, to say you don't have to check for 3, 4, 5 because the number is divisible by 2. 6 is divisible by 2. So you don't have to check again for 3, 4, 5, right? And we need to end there. So I'm saying is prime equal to true. Okay. And here I'll say if n, that the number that we have, mod num1. Num1 is the value between, oops, sorry, this is n, or we'll just put as num. 2 to num1, right? What is num1? What am I doing? N is the number, right? So you have to check from 2 to n. And here we are checking num1, maybe that's okay. Right? So we are generating range of values from 2 to n, right? So if I'm checking if 10 is prime number or not, or 10,000 is prime number or not, first number, right? I'm checking 10,000 is prime number or not. So I need to take that value, okay, n, and you need to take n and we need to divide by 2, 3, 4, 5, all the way up to n minus 1. So the num will give us 2 to n minus 1, and this n we are going to check. Okay, so if this is equally perfectly divisible, that means if none modulus n modulus num is 0, okay, perfectly divisible, isn't it? Then we will say is prime equal to false, because now we know that it is not a prime number, isn't it? It's not a prime number. So is prime equal to false? And once you are out of the loop, okay, now you see, if it is false, when you know it is false, like for example, 6, you divide 6 by 2, okay, 2 comma n, so you get 2. So when you divide 6 by 2, you know it is not a prime. You say prime equal to false, and then you need to break from, you don't have to continue executing further. So now you know that number is not a prime, then why do you have to check for next number? So break is a command. We are learning break for the first time. So break is a command which will throw you out of the current loop. Break is a command which will throw you out of the loop. So which loop are we in? We are in this loop, not in this loop, right? This break is in this loop. So you'll be thrown out of this loop and you will still be out in the outer loop. That will still have to check for more values. But at least from this loop, you are thrown out because you know that now it is not a prime. So you don't have to, you don't have to check further. Now here I will check if is prime. Okay, that means if prime is true, I will print the number, and the number is n. And I will say n equal to, and you can define this as, I will pause for 30 seconds for you to just recollect what I have done, and then I'll repeat it. All right. Any question here? No? Okay. So I'm taking each value from 10,000 to 50,000, and I'm assigning a variable called is prime, okay, to true, assuming that value that we are taking between 10,000 and 50,000 is a prime. I'm assuming it's a prime. And now this step will tell me that no, it's not a prime. Or if none of these, like if this is not executed, this is always false, then we know that that number is a prime because it's already written as prime. But moment it becomes true, it is false, right? So here I'm checking outside this loop, but within this loop, because I have to check for multiple values, isn't it? So I'm checking if number is, okay, prime value is true or false. If it is true, right, is prime. Okay, so is prime will be either true or false. Is prime will be either true or false. I'm saying if true or false. If true, print this. If false, then you don't have to print it, isn't it? Okay, and meanwhile, once you are done here, I need to print blank, otherwise this print will happen continuation from the previous one. Now let's run this and see. Okay, so see, these are all prime numbers. These are all prime numbers. Okay, it's checking. To make it more efficient, you don't have to go up to n, right? You can even say n divided by 2 plus 1. That means if I'm talking about 10, if I go up to 5, it's enough. I don't have to go to 9. Okay, because after 1, you have 2 as a divisor, right? So, you don't have to go all the way up to 10. If you just divide by 2, also it's enough. Okay, so if you're checking if 100 is a prime number or not, if you check up to 50 is enough, right? You don't have to go up to 90, 70, right? Because those will be anyway less than 2. So this is what I'm doing. Now this is taking so much of time, right? Now if I stop it and if I run it again, let's see if it is any faster than the previous one. It is faster, isn't it? Okay. So it is still like 14,000, 15,000. Okay, we'll stop it. And what I'll do here, we'll make this as 40,000, right? Then it should be done faster. So these are the values which are prime numbers between 50,000, 40,000 and 50,000. Okay, still in 40s, right? Okay, I mean, you understood the purpose, right? So here I will say 42,000, okay? Between 40 and 40,000 and 42,000. Okay, so this is how you generate prime numbers. Okay, so you check a number, you divide by all the values up to half of that number. Okay, and if it is divisible, okay, then that number is not a prime. And if that number is not divisible by any other number, then we say it is a prime. Okay, so these are your examples. Now we will learn some pattern design. Okay, let's see. Okay, so okay, so how do you print single star? You print single star like this. We saw yesterday, right? And if I need to print 5 stars, I will say for I in range 5, and you will get 5 stars, right? So you get 5 stars like this. Okay. Okay. Now, question here is, I want to print, okay. Okay, I want to print 5 stars like this. Okay, 5, which is okay, which is easy. We did it yesterday, but I want to repeat this 5 times. So it's like square of stars, isn't it? So to print it in one line, we say comma and equal to space you give. And now when you run it, okay, you get, right, star like this, 5 star like this, right? Okay. Now I want square, right? So whatever I have done here, this entire thing has to be repeated 5 more times. So this entire thing. So I'll put another loop for j in range 5. Okay, and I will put this entire thing inside this loop. So this inner loop is generating 5 stars, and the outer loop will run inner loop 5 more times. So you get 5 stars, 5 stars, 5 stars, 5 stars, 5. So you get 5 into 5, 25 stars. But you see, we have given end equal to space. So it is printing space at the end. I want to break after printing 5 stars. So this is printing one row, right? You printed one row. After printing one row, you want to stop it. Okay, or you want to move it to the next line. So this is where you will give print equal to nothing, right? So now when you run it, after printing one row, it will break. Now see this, this is outside this loop, but inside the outer loop. So you have two loops here, right? Outer loop and inner loop. So what happens when you have, okay, now we are talking about, two different loops, outer and inner loop, right? So when you talk about outer loop and inner loop, you have your outer loop running one time, but before it finishes, right, you have inner loop. So inner loop will finish running 5 times. Then it goes here. That means one outer loop will make your inner loop run 5 times in our case. Then second time when loop starts, okay, so let's say we use different color. So second time when loop starts, okay, it goes, again it runs 5 times. It will complete the inner loop and then complete the outer loop. Third time again when it happens, right? Third time again when it happens one outer, you have multiple inner loops. You have multiple inner loops to complete one outer loop, right? So this is what is happening in our program here. Okay. So now when you run it, see, you get 5 stars like that. Okay. Next. And see, when you're doing programming, right, and if you are new, I'm talking about those who are new to programming, okay, don't always think that you should get the correct output in the first attempt itself. Okay, you have to think, try to get, make your first attempt. And if it is not what you want, you go back and check which line, okay, needs to be modified. You go and you modify those lines. Okay, you go and you modify those lines. Now, if that modified lines gives you some expected outcome, great. If not, again, you think why, okay, you are not getting what you want. Why? Okay, keep asking yourself why I'm not getting what I want, why I'm not getting what I want, why I'm not getting what I want, right? Then you need to fix it again. You fix it, and then definitely you will be able to get what you want. Okay, so idea here is, okay, to know your own program. Which line is, now when you see the output, you should be able to know which line is giving that particular output. Okay, which line is giving that particular output, so that you can go and fix it. Make sense? Okay. Now I'm going to modify this. I want to modify this. Okay. This is the same. No, I will just copy this. Okay. I want to print a pattern like this. 5, 4, or let's make it like 1, 2, 3, 4. 1, 2, 3, 4. Okay. So 1, 2, 3, 4. I want to create pattern like this. Okay. I want to create pattern like this. Right? How can I do that? So tell me what is changing here. Okay. Is the number of row changing? No. So this J indicates J is for the number of rows, isn't it? So number of rows is not changing. Okay. So number of rows that you are doing is not changing. So J in range 5 will not change because you're getting those 5 rows and that is doing its job. What should change is this inner when you print the star. Okay, we gave 5, so it is printing 5 stars in every row. But now, instead of giving 5, it has to first start with 1. Okay, next time it should become 2. Next time it should become 3. Automatically, it should become 1, 2, 3, 4, 5. Right? It's not about fixed value of 5. The number should keep on changing. It should automatically increase. Right? So one option is you create a variable C equal to 1 and you put 1 here. Okay? So it becomes 1. So 1, your job is done. Now after you print, okay, and before it changes to the next line or immediately after it changes to next line, before it goes for round 2, C should become C plus 1. So if C was 1 before, it should become 2 now. Okay, next time it should become 3. Okay, so C should change, isn't it? So I'm creating this new variable C, and this C should keep on changing as you move along. So now you see, yeah, see, we got what we want, 1 to 5 stars. Now, our objective is always to make the program more efficient. Can we do something with less number of code, with less number of iteration? Okay, that's the whole objective of programming. So can I do it without introducing C, a new variable? I don't want to introduce C. I want to do it within whatever we have. Okay, so see here, J, when your I is running for the first time, the inner loop is running for the first time, J value is 0. Second time when you run, J value becomes 1. Third time when you run, J becomes 2. So it is 0, 1, 2. I need 1, 2, 3. It is 0, 1, 2. That means if I say 1 plus J or J plus 1, this should do the trick for us. Okay. So we are able to generate this pattern now. With me. Okay. Now let's make some changes to this. Let's make some changes to this. What change? So I'm going to copy this again. This time, I want to print 5, 4, 3, 2, 1 pattern. Okay, we did 1, 2, 3, 4, 5. Now I want to do 5, 4, 3, 2, 1. Okay, can we do it? Of course, we can do it. See here. If I put 5, okay, instead of 1 plus J, it will be 5, 5, 5. But initially I want 5. But second time I want 5 minus 1. Third time I want 5 minus 2. So if I say 5 minus J, so remember J is first time 0, second time 1. So first time it will be 5 minus 0. Second time it will be 5 minus 1. Third time it will be 5 minus 2, isn't it? So this does the trick for us. Now when you run it, see, you get 5 to 1 pattern. Yes? Okay. We'll do one more program with for loop and then we will move to while loop. Okay, so let me print one more pattern. Okay, we'll take this same pattern here. Okay. And the change that I want to make is, this is like a rectangle triangle, isn't it? This is like a rectangle triangle. I want to make this as isosceles triangle, inverted isosceles triangle. One space, 1, 2 spaces, 1, 2, 3 spaces, 1, 2, 3, 4 spaces. I want to give 4 spaces. Now, how do you work? See, in what way this is different to the previous program? Number of rows, same, perfect. Stars, 5, 4, 3, 2, 1, perfect. Right? Then what is the difference between what you see and what you want? Here, you have to take care of spaces also. You have to take care of spaces also. So this program is like, okay, putting two things together. Like stars, you have 5 to 1, and spaces, you have 0 to 4. Right? So first you print the spaces. See, in previous case, there's no space on the left-hand side. So we never thought about the spaces. Spaces on the right side anyway, it will be default spaces, right? But here we have spaces on the left. And when you have spaces on the left, you have to print spaces also. So I need to put, this is to print star, but before I print star, I need to print spaces. And spaces is from 0 to 4, not 1 to 5, 0 to 4, right? First row 0 space, then 1, 2, 3, 4, so on. So range of J will do, right? And then instead of printing star, this you will, you will have space. And at the end, we will give nothing. Okay, we don't have to give space at the end. Now let's run and see. See, this is exactly what we got. So since spaces are on the left, we have to think about spaces as well.
Yes, sir.
Right? Perfect. Okay, so this is how, okay, you can try. Okay, see, and today when I upload the material, right, in the blog site, you will see there are some examples, some assignments which I would add there. Try to solve those assignments over the weekend. Okay, try to solve those assignments. Okay, if you can solve them, it is like, means that, you have understood the concept. Try to solve those assignments. Okay, so I'll give you one more assignment here itself in the program here. Okay, that instead of printing this inverted isosceles triangle, okay, instead of printing the inverted isosceles triangle, I want you to print, okay, the other ways. Okay, so this is the assignment. Okay, and also solve assignments from the website. Okay, perfect. Be good. So I'm going to move this. Okay, so we have done enough programs, right? A lot of programs for using for loop. I'm sure these programs, if you practice by yourself, you will understand the concept. Okay, you will not miss any concept. Okay, what I want from you is commitment. Okay, I want you to practice. All right. Okay. Now we'll talk about while loop. What did we discuss about while loop? We said that while loop is a technique of looping. Looping means running multiple times, right? So it's a technique of looping where you don't know exactly how many times you need to repeat, but you know the condition. You know the condition when to repeat. Okay, you know the condition. Okay, you should have the condition. Okay, so now let's say I want to print hello. Okay, till user says no. Okay, so I want to print hello, let's say. So write a program to print hello till user says no. Okay, so you say print what? Hello. Now I need to repeat it, right? Now we don't know how many times. User can say after one iteration only. After one iteration only, user can say no, don't print it anymore. Or it might be after 1,000 iterations, user says no, don't print anymore. Right? We don't know how many times to repeat. This is case for your while. Now, while is always followed by condition. So this is how you use for loop. When we use for loop variable in range. And there are other ways to do it for loop. We will see. Okay, when we get into string and list, we'll see how for loop can be used there. But understand, for loop is not just one single thing. For loop has of course, it has three different components: variables, in, and function to generate values, which you can replace with something else. As long as you are able to tell for loop when to start, where to start, okay, when to end, it is cool. Okay, and we'll see different versions of for loop in the next topic when we go to strings or list. Now here, while is different. While is different because while needs condition. Okay, so before you get into the loop, you need to see the condition. Condition has to match. Okay, and this has to be like true. Well, then it will go in. Condition is true, only it will go in. Okay, so this is also called as entry check looping technique. So entry of your program is checked. Should you run even one time or not is checked. So entry check. Okay, then you might have something like exit check. Okay, so exit check is okay. You continue. Okay, and at the end, I will check whether should I stop or not. Now, entry check looping and exit check, right? Now, if you look at this program, okay, what logic do you think will suit here? Entry check will suit here or exit check will suit here? Think of entry check like getting into a movie theater, right? They'll check your ticket at the entrance itself. Okay, if you have valid ticket, you will go in. Otherwise, they will not allow you to go in. Okay, so exit check is like your ticket that you buy for, say, metro or, okay, so you get in at the time of exit, you have to show your ticket, right? That's when you are able to come out, right? So this condition, when I say print hello till user says no, okay, should it be entry check or exit check? Which logic do you think should it be more relevant? Okay, so see, when you say entry check, that means in the beginning itself, your entry can be wrong, your condition can be wrong, and you don't even do one time. So entry check, okay, it is possible that your repetition may not even have one, right? You may not even repeat even once. But when you talk about exit check, so you go in, right? So you're allowed to get in, but you're not allowed to come out. So exit check, at least one time the loop will run. Entry check, minimum, okay? Minimum, I'm saying, it may be the condition is false and you don't even get into the loop. Okay, but exit check is when at least one time it is run. So for example, here, when I say while true, I'm not checking condition directly, I'm saying true. This is like your exit check. So you go in, it's like door is open. While true is like opening the door, you get in. Okay, nobody's checking whether you're valid audience or not. You go, you print hello, you watch your movie, and when you try to come out, then you realize that, oh, you are not able to come out because you do not have valid exit criteria. So in this program, if I run here, okay, so you get into the loop without any problem, but there is no exit criteria. You don't know how to come out. Okay, so you get into what you call as infinite loop. You get into infinite loop. Okay, so now I can put a break. You know that we discussed about break in the for loop, that break is a command which will break you from the current loop. It will throw you out from the current loop. So if I put break here, it will throw you out from the current loop. Right? It will throw you out of the current loop. So now when I run it, okay, so one time program is run, one time hello will be done, and then I'm saying break. So you are thrown out of the loop. So one time hello you get. So this is like implementing your exit control loop, where exit from the loop is checked. And if it is valid, you are thrown out. Otherwise, you are not thrown out. You become an infinite loop. Okay. So now let's say we're talking about entry control loop, right? So while, okay, now I say continue equal to n. I'm saying continue equal to n. So value of continue is n. I'm checking, is continue equal to y? Then you say print hello. So see, this is an entry control loop. I'm checking the condition before you print hello. So here it is possible that continue is n, not y, and you are not allowed to get in, you go inside the loop. When you don't go inside the loop, okay, so hello will not be printed here. Or if I call this as hello 1, let's say. Hello 2, and this is hello 1. So hello 2 is not even printed once because entry control loop, you are not allowing to get inside the loop itself. The condition is there with the while, okay? While will decide whether you are allowed to get in or not. Make sense? So here you see, here you cannot stop it from happening at least one time, right? here it is possible that you may not even enter into the loop. So this is like to show you the minimum value, okay? Okay, and here both are implemented using while. In C++, Java, you have do while, but here there is no concept of do while. It is all while only. Okay, so depending on the business problem, you will add the given condition. Now here, for example, I can show you the same example using both. So here I'm saying hello true, get in. And now I'm saying to the user, do you want to stop? Or I'll say user input equal to input, enter and to stop. Enter and to stop. So here I will go and check if user input equal to n, or I can say whatever be the user input, convert this into lowercase. And now I'm saying with n. So it is possible that you might enter capital N, right? Now here we have one character, so you can check for capital and small both. But when you have to write sentence, and then if you have to check a value in that, it becomes very difficult, right? So best thing is that you convert the text that you have into either lowercase and uppercase, something that you know. So all the characters will become lowercase. Then you can easily compare lowercase with lowercase that you have. So here I'm saying enter n to stop. If the user says n, then you break. So even if it is capital N, I'm converting into lower n and I'm saying break. So break, will always be in some condition only, okay? Because if you use break without condition, then the program will end anyways. So, the right implementation of break is to use it in a condition. So here I'm saying condition, if user input equal to n, then you break. Okay, so let's run this. Now I'm saying hello one, n to stop. No, I will not end. I will enter something else. Hello one. Okay, hello one, hello one, hello one. Now you say n and you say stop, it stopped. Okay, so this is how you can implement this concept, right? Print hello till user says no. Here, okay, before only you will take the input from the user. Okay, enter n to stop. Now I'm going to say user input dot lower equal to, so I'm saying n to stop, right? So dot lower not equal to n. So if you press n, you are stopping, right? So I'm checking, is it not equal to n? No, not equal to n. Then we need to proceed ahead. Then you say hello to. And again, I'm going to say here, because that input is outside the loop, isn't it? But I have to have one inside the loop so that, okay, if you want to print first time, okay, you print it first time. But next time, again, I have to input from the user and check. Okay, so let's run this and see. So hello one, okay, I'll start enter. Okay, hello one is printed. Hello one is printed. Now I'll say n. Last time I give capital N, right? Now small n, right? This time I'll give capital N. So what happened here? Yeah. So this is loop 2. Sorry. Like what happened here? Okay. So first loop is stopped because we said n and it broke, right? The break executed and you move out of the first part. Now you're in second part. This is your loop 2. Enter n to stop. No, I will not enter n to stop. I'll enter something else, blank space. So see, hello 2 is printed. Hello 2 is printed. Now I will say end and hello 2 will also stop. Okay. So what I'll do is I'll stop here for today.